Hello everyone, myself Riddhi Agarwala from VIT Chennai, going to explain the topic application of context-free grammar in natural language processing. So let's proceed with what is grammar and what is context-free grammar. So in the given diagram, as can be shown, there are four types of grammar as shown in the given figure. So let's start from the type 3 grammar, which is basically the regular grammar. The regular grammar is the grammar which is used and recognized by finite automata machines. Then comes our second grammar or type 2 grammar, which is context-free grammar, or the grammar which is used to generate context-free languages, which is usually recognized by push-down automata. Then comes our type 1 grammar, which is context-sensitive grammar, which is the language generated by linear bound automata. Then comes the recursively immutable grammar or the unrestricted grammar in type 0 grammar, which is basically used in Turing machines. So going forward towards the context-free grammar, it is basically divided into left hand side and the right hand side, where the left hand side has only a variable of 1 and right hand side has no restrictions. So going forward to the formal definition of context free grammar has mainly four tuples, basically v, t, s and p, where v is a set of variables which consist of non-terminals, set of terminal of t which is consist of terminals, and S is the starting terminal, and P is the production set of rules describe how variables can be set and rewritten using the forms of variables, that is non-terminals and terminals. What are the examples of context-free languages? Context-free languages or the grammars can be created using variables, terminals as stated above, but there are some production rules which follows to get a context-free grammar. So here we can see the start symbol E produces either E plus T, E minus T or T in the first step. In the second step, which is T, it's also a non-terminal which produce T multiplied by F, T by F and F. And then comes the F which produce ID and E. Then here it's the derivation of context-free grammar which can be seen. So here it's the start symbol E, applying the rule 1, it gets E plus T, and then it applies the rule 2, which gets T multiplied by F, and then apply the rule 3, it gets F tends to E. And the final sentence became E plus T multiplied by F. Now I am going to explain what's the role of context-free grammar in natural language processing. Actually, context-free grammar plays a crucial role in natural language processing by providing a natural and formal framework for describing the syntax of a natural language. It's used to build a parse tree and analyze its structure by making it more clear, by taking a sentence and breaking through it and making it more machine learning formatted. So it can be done in basically three ways as stated. So it's basically syntactic analysis, semantic interpretation, and third comes the language generation. So in syntactic analysis, what it does is breakdowns of sentences into grammatical components, allowing a deeper understanding of the language structure. Then comes the semantic interpretation, where the hierarchical form of parse tree has been noted. It is like a tree structure which is very much simple of a complex string, and it's a very simple structure which is defined, which can be easily explained and which can easily be understood by any of them. So the meaning of sentences is being inferred using the semantic interpretation step, and then many question answering and dialogue systems is being repeated. Then comes the language generation step, where context-free grammar prediction rules can be used to generate grammatically correct sentences and can produce any form of the grammar. Then how context-free grammar is used in parse tree, or basically the syntax tree. So a syntax tree, also known as parse tree, is a tree representation of different syntactic categories of a sentence, of a basic sentence. So for example, I consider a sentence which is I drive a car to my college, basic sentence. The syntax of these words is how the syntax tree divides it, is describing its noun, pronoun, subjects, verbs, phrases, and are sequenced in. So it basically define how the sentence have many words and how it can be defined. So it basically build a syntax by breaking down the tree into its constituent parts, and then generation of grammatically valid sentences, and then it reveals the grammatical relationship between the elements and the sentences. Then comes the main two steps, which is very helpful in NLP, that is chunking and chinking. What does the chunking do? Chunking basically identify and extract the meaningful sentences and sequences of words. And what does chinking do? Chinking remove the irrelevant or the unwanted elements from a sentence. So it basically work together for performing an NLP operation and AI generation code. Then comes the context-free grammar's role in compilers. If we, as we all know, that what does a compiler do? A compiler converts a high level language into a machine level language or an easy executable form. So it basically describes how a basic define of a programming language and then corresponds to the programming language, guiding its parsing and translation into a machine readable form. Basically, it involves three steps here also. It's basically lexical analysis, which is a tokenization form. It basically take down the input text into smaller text in the form of tokens, which are then identified, and then structure of the input language is taken. Then comes the compiler. uh, it's a abstract syntax tree. Already I have explained you the topic of syntax tree or the parsing tree, which is a hierarchical representation. Compilers do the tokenization, then do the division of the parse tree using parse tree, and then it compile it to generate the machine code. And then this machine code would be an executable program that can be processed through natural language in. And then how it is useful in programming language, there are a lot of programming languages today as well, starting from Python, C++, and many more. So what does it do? Basically define a language, define a syntax for the code, then do the parsing, then do the compiling, and then the proper designing of the language. So in context free grammar in XML, that is extensible markup language. So here comes the extensible markup language that defines a set of rules in both human readable and machine readable form. So basically it is a basic software and hardware independent tool which can be used for storing and transporting data. So how it is stored, it is maybe in the document type, it can be of schema type, which can be stored in the form of relax ng, and also use CFG like constructs to describe the structure of XML documents, and then do the validation against the schema of the specified schema, ensuring data integrity and constituent structure. Coming to the algebraic expressions, context-free grammar in algebraic expression. As I have already been used with an example showing you the terminals coming with the non-terminals, and if it's given how we can use from the starting symbol, I've already explained in the further slide. So all those is used to create an algebraic expression which can be directly fed into NLP machine learning model of the training model, and then while testing and getting it, we can easily get and create the model, which is basically use the problem of parsing, and where the parsing of the an algebraic expression enabling their interpretation and the evaluation by programming of the computers. And then comes our imperative programming language. So first coming, what is imperative programming language? It's basically a paradigm of computer programming where the program describes the steps to change the states, which describes what a program should accomplish. Imperative program explicitly tells you the computer that how it should be accomplished, how it can be done, what can be done in it. So basically there are mainly four types, it divides into four parts. So mainly the statement structure in the code, where the we define the basic syntax. For example, there's blocks, these are conditional blocks, if else blocks, these are for, these are other, and then there are blocks where we describe the statement structure. There must be syntax in the given expression. And then comes the expression where it should be for loop, then for the syntax should be the left side, little right side to it, and then how we do it. Then comes the logical, how we define the logical expression, how we define the arithmetic function call expression, and how we all do that. That does the work of imperative programming. Then comes the control flow, how it flows through the for loop and do other compilers and interpreters, look after other compilers and interpreter errors, and then convert the translate the imperative language code into executable readable form, which is done by imperative grammar using context free grammar. There are vast application of NLP which can be done using the steps I have said you, using XML, creating XML documents, by doing our things like chunking, chinking of the words to make it more clarified, and using more statements, and a lot more. Then what are the application of NLP which is used in our daily life? Basically, starting from chatbots or chat GPTs, which we use, that are basic chat GPT tools for creating and getting all the answers we want to know about any topic. Starting from basic daily life questions like what to do next, how set an alarm, everything we can do using chat GPT, every questions we can. Then comes the speech recognition model, which we have in our phone, that is Google Assistant model. We can ask him, give any command to it to perform tasks. And then comes the sentiment analysis model, which is used for expressing a piece of text, which is useful for monitoring social media and product reviews. It is basically now set for it, and many more applications for it is also been produced and which can be shown. Moving forward, I came to the conclusion of the project and conclusion of this topic. Context-free grammar is a very versatile and a powerful tool that is used for providing the foundation for describing and processing a wide range of programming that constructs to natural languages. And the ability to capture hierarchical structure languages in indispensable part is very helpful for today's world. So making it up to this, I will take a leave. Thank you very much for paying attention and listening to it. Thank you very much for your cooperation. Thanks a lot.